So, hello everyone again. This is lecture 2 part 2 of semiconductor electronics materials devices and simple circuits. In the previous part of this lecture we started with the band theory of solids. Let us start the further discussion on that topic only, and then we can move on to the third topic, that is the intrinsic semiconductors. So, let me start the topic here. So, I am Sameer Lavankar. Let us begin our discussion. Okay. So, right now we are on the second topic. In the first part, in the lecture 1 of this part series, we have already done with the introduction. Let us move with the today's discussion on band theory of solids directly. Okay. So, in the previous discussion we have concluded with the region A, that is of isolated atoms, and region B in which there is an energy gap with the energy states of 6n and 2n states being converted into continuous bands. Okay. Now, what we are trying to simulate in the next part is, let us try to understand the complete concept when the amount of distance between the atoms is further decreased. Okay. So, in the previous concept what we understood is that there is a continuous band in the L is equal to 1 state also, and there is a continuous band for L is equal to 0 state also, and there is an energy gap. Okay. Fine. So, next thing is the lowest energy state, that is a split from the upper atomic level, appears to drop below the upper state that has come from the lower atomic level. Okay. So, whatever is written here I will try to make you understand first. So, they are just saying, that the lowest energy state, that is a split from the upper atomic level, appears to drop below the upper state that has come from the lower atomic level. So, basically they are trying to say is that there is a lowest energy state that is split from the upper atomic. So, as you can see that it is a split from the lower atomic level to drop below the upper state. So, as you can see that there are some portions of the upper atomic level that has dropped below the lower atomic level. So, basically what was happening is this was energy state. So, this energy state was supposed to be lower and this energy state was supposed to be higher. So, now what happened is, due to the difference in the energy fluctuation, what happened was that this energy state for some of the portions appeared to be at a lower state than the lower portion. This happened in some region called as region C. So, what is this? What we are trying to conclude from this is that in this region C in the figure, no energy gap exists. Quite evident, there is no energy gap existing here. So, basically what happens is the complete energy gap for the conduction band and the valence band are very secured here. Okay. So, basically no amount of energy is required. So, basically they can try to move from one place to another place very easily. The valence electrons can try to move from one place to another place very easily. So, in this region C in the figure, no energy gap exists where the upper and the lower energy states get mixed. As you can see that the upper and the lower energy state get mixed. Okay. Finally, if the distance between the atoms further decreases, we try to decrease the distance much further, the energy bands again split apart and are separated by an energy gap, e.g. region D in the figure. So, again what happens is, let us say after this again there is an energy gap, as you can see. So, this is for the continuous band here for the L is equal to 0 state, and this is for L is equal to 1 state. So, as you can see there is an energy gap again occurred here. Okay. So, basically these were the three regions which you need to understand. So, basically we can say that insulators may be in the region A, the region C would be of conductors, and region B would be of your semiconductors. Okay, so and let us understand again. So, finally, if the distance between the atoms further decreases, the energy bands again split apart and are separated by an energy gap, e.g. as you can see in this figure. Okay, so this is also e.g. and this is also an energy gap. Okay. Next thing is the total number of available energy states 8n has been reapportioned between the two bands, 4n energy states in each of the lower and the upper energy bands. What they are trying to say is, so basically in the previous chemistry concept we understood that there are total 8n energy states. So, that 8n energy states are divided into 4n states downwards and 4n states upwards. If you remember correctly, in the region A the energy states were 2n states here and 6n states here, but in region D it is 4n states here and 4n states here. That means the division of the energy states has been done at a equal order for the region D. Okay. So, that is only been explained here, that the total number of available energy states has been reapportioned between the two bands, that is 4n states each in the lower and the upper energy bands. Okay. Here the significant point is that there are exactly as many states in the lower band as there are available valence electrons from the atoms, 4n. So, this also we concluded in the starting discussion of this only, that total there are 4n electrons. What was happening in region A, that the 2n electrons were residing in the L is equal to 0 state and the remaining 2n electrons were residing in the 6n state, out of which, so basically there are 4n 6p states which are being vacant. Now, what they are trying to say, let us say what happens is, here there are 4 energy states in the lower band and there are 4 n electrons also in the lower band only. Okay. So, that is the significant point here. So, the significant point is that there are exactly as many states in the lower band as there are available valence electrons from the atoms, or 4 n. Okay. Therefore, this band called the valence band. So, basically this is called as your valence band. So, basically region D is your semiconductor, region C is your conductors and region A is your insulators, if we take discretely all the topics. Okay. So, therefore, this band called the valence band is completely filled while the upper band is completely empty. So, as you can see, this is completely empty, as in there are 0 electrons here. Okay. So, the upper band is called as the conduction band. So, this is the conduction band. Fine. So, that was the complete concept of, I guess, band theory of solids. Yes, so that is the conclusion of your band theory of solids. So, what are all the things which we understood from this is, first of all, that there are 8n valence states, right, and there are 8n energy states, not valence state, I am sorry, there are 8n energy states and there are 4n valence electrons, right. There are 4n valence electrons. So, basically what is happening is that these electrons would be residing somewhere. So, if they are residing in some sort of this portion in which there are isolated atoms or they are very far from each other, then 2n electrons will be residing in 2n states and 2n electrons will be residing in 6n states. And when we try to decrease the distance, so this is basically how we are trying to decrease the distances. So, there will be a continuous band due to energy fluctuations, there will be an energy gap. If we increase it further, there will be a joining in region C, as you can see, and if we if it decreases much further, there will be a joining in region C, and if we decrease it much further, then there will be a gap again, as you can see in the figure. So, this is one energy state and this is your another energy state. Okay. So, the below one is called as the valence band and the upper one is called as the conduction band. Okay. Let us move on. Okay, let us start our discussion further again on the classification topic only. So, the lowest energy level in the conduction band is shown as EC. So, as you can see, this is the complete conduction band, out of which the lowest energy. So, this will be the lowest energy here, that is denoted by EC. Okay, and the highest energy level in the valence band is shown as EV. So, basically this is the complete valence band, out of which this is the highest energy. So, this highest energy is called as your EV. Please remember, no random line is called as your EC, no random line is called as your EV. The lowest value of the conduction band is called as EC and the highest energy state or highest energy level of the valence band is called as your EV. Okay. So, above EC and below EV, there are a large number of closely spaced energy levels. As you can see, these are nothing but your energy levels only. Okay. So, these are nothing but your energy levels. As shown in the figure, the gap between the top of the valence band and the bottom of the conduction band is called as the energy band gap. Okay. So, this is only the explanation being done here. So, the distance between the gap between the top of the valence band. So, basically this is top of the valence band and the bottom of the conduction band is called as the energy band gap, also denoted by Eg. It may be large, small or 0 depending upon the material. So, till now our understanding is this much, that we can understand. So, when it is very large, then we can say that those are basically your insulators. When it is 0 or very close to 0, then those are metals, 0 for metals, and when it is small, then those are called as semiconductor devices or semiconductors. Okay. So, this is the classification of metals, semiconductors and conductors. Okay. Let us understand more about regarding this topic. Okay. So, these different situations are depicted in the figure and discussed below. So, let us see for the case 1. So, what happens in case 1? So, this refers to a situation as shown in figure A. So, please refer to the figure A here. So, this is the figure A being explained here. So, quite evident for till now what we know is the below band is called as the valence band, the above band is called as the conduction band. Okay. The below of the EC, below of the conduction band is called as EC, the above the valence band is called as EV. Okay. Let us move on with the further discussions now. Okay. So, let us take the first case in which we are trying to refer to a situation as shown in the figure A. One can have a metal either when the conduction band is partially filled and the balanced, sorry, this is not balance, it is valence band is partially empty, or when the conduction and valence bands overlap. So, what they are trying to say is that when do we consider a material to be a metal? We can consider them to be metal when it is having overlapping conduction band, or when the conduction band is partially filled and the valence band is partially filled. Okay. So, these two can be the ways in which we can classify the material to be a metal. Okay. So, either these two both should be partially filled, or either this to be a overlapping conduction band. So, overlapping is already known to us, it is very evident, but this may not be evident, but you can remember this, that if these are partially filled, then that also is called as your metal only. Okay. So, that thing, this thing is explained, that one can have. So, one can have a metal either when the conduction band is partially filled and the valence band is partially filled, or when the conduction and the valence bands overlap. Okay. When there is an overlap, electrons from the valence band can easily move into the conduction band, quite evident. So, basically what these bands try to say is, they are just trying to tell you the different energy states in which the valence electrons can be, right. So, basically this is the complete area, or this is the complete energy. So, basically there are different lines here, right. So, different lines suggest you the different energy levels in which the valence electrons can be in. If it is overlapping, that means there is no energy gap required for the movement of the valence band electrons into the conduction band electrons, and hence this can be said that the movement is very easy over the complete area. Okay. Fine. So, this thing has also been explained. Next thing is, when there is a overlap electron, so this thing is explained. Next thing is, the situation makes a large number of electrons available for electrical conduction, quite evident. When the valence band is partially empty, electrons from its lower level can move to higher level, making conduction possible. So, that thing has been explained here. Therefore, the resistance of such materials is low, or the conductivity is high. Okay. So, basically what the concluding statement of this case is nothing but that these two can be the cases which can convey you that the material can be classified as a metal. Okay. Fine, let us move on to the case 2 here. Okay, so the case 2 is basically shown in your figure B here. So, what happens that in this case as shown in figure B, a large band gap, that is Eg, exists, that is Eg is greater than 3 electron volts. As you can see, Eg is greater than 3 electron volts here. So, what will be the classification this time? So, there are no electrons in the conduction band. As you can see, there are no electrons, it is written here, it is empty conduction band, and therefore no electrical conduction is possible. Okay. So, in the first part of this lecture series, we have understood that the conduction occurs, or the passage occurs due to the movement of electrons either from the valence band to conduction band or inside conduction band, right. So, there were 2-3 different agendas which you need to consider for the conduction of electricity, right, or the conduction of electricity, right. So, basically as there is an empty conduction band, that means there are no electrons in the conduction band, and therefore no electric conduction is possible. Okay. Note that the energy gap is so large that electrons cannot be excited from the valence band to the conduction band by thermal excitation, and hence this is the case of your insulators. Okay. So, what is the next conclusion from this part is that if the value of energy gap is greater than 3 electron volts, then the first of all the energy conduction band will be empty, as there will be no conduction possible, and second thing is that the amount of energy required for the excitation from the valence band to the conduction band is much higher, hence the conduction is very low or nothing, negligible or no basically, and hence these are nothing but called as your insulators. Okay. So, this is the typical example or typical formulation or typical way in which the insulators can be explained. Okay. Next thing is case 3, that is this situation is shown in figure C. So, this has been explained here. So, here a finite but small band gap, that is Eg less than 3 electron volts exists. Okay. Because of the small band gap at room temperatures, some electrons form valence band, can acquire enough energy to cross the energy gap and enter the conduction band. So, basically now because the energy gap is less, therefore, some electrons here can go into this electron state here. Initially it was initially the conduction band is empty, but because now the energy state can be such that it can move from this state to this state, hence because of this movement there can be conduction of electricity. Okay. So, because of the small band gap at room temperatures, some electrons from valence band can acquire enough energy to cross the energy gap and enter the conduction band. So, basically this is your conduction band, and this is your valence band. Okay. So, this thing is explained, this thing is explained. These electrons, though small in numbers, can move in the conduction band. So, they can move in conduction band, and hence it can impart conduction. So, basically electrical conduction can be imparted if there is, if the value of band gap is less than 3 electron volts. Okay. So, this thing is also explained. Next thing is, hence the resistance of semiconductors is not as high as that of the insulators. Quite evident, because the energy gap is very less as compared to insulators. Okay. In this section we have made a broad classification of metals, conductors and semiconductors. In the section which follows we will learn the conduction process in semiconductors. Okay. So, that is, I guess, that is the end of your classification of metals, semiconductors and insulators. So, just let me conclude the final concept which we understood in this last concept here. So, basically we have materials, and we have the energy gap, right. So, for let us say metals, or let us say conductors, next thing is let us say insulators, next thing is your semiconductors. Okay. So, if the Eg value is 0, then that means that the material can be classified as a metal or conductor. If the insulators, if it is insulators, then that means that the value of Eg is greater than 3 electron volts, and greater than 3 electron volts, and if it is semiconductors, then that means that the value of Eg is less than 3 electron volts. Okay. So, that is the complete conclusion of this statements here. Okay. And also in this complete part we also understood the concept. Please remember this also, that the lowest part of the conduction band is called as Ec, the highest part of the valence band is called as Ev, and the gap which remains is called as Eg, right. Thing remaining is I guess that thing, this thing is also been explained in the this part of the lecture only. Let me stop it here only. In the next part I will start with the new concept, that is intrinsic semiconductor. Then, so now we will start with the basic agenda of semiconductors, and then we can move on further with the extrinsic, etc. Okay. So, let me stop it here. Let us meet in the next part of this lecture. So, thank you so much.